Alright, so today we are now on our first topic on second quarter, which is faults. So we will start. For this lesson, the following objectives will be met at the end of this video. The first one is to describe what is fault or what are faults and to determine the different types of fault. Okay, yeah. So before anything else, let's have first our review. Um, this is very important before we start learning faults. So let's go back to the tectonic plates. I believe you are fully aware what are these tectonic plates. These are the plates that makes our continents and islands. So these are the large pieces of rocks that makes up the Earth's crust. So as you can see on this side of the video, these are the example of plate tectonics, right? So you know already that we have four layers of the Earth. We have crust, mantle, outer core, and inner core. And the most important layer of the layers of the Earth that we'll be going to tackle is the asthenosphere, which is located in between crust and mantle, or the upper part of mantle and below crust. Now let's talk about asthenosphere. Asthenosphere, as I said earlier, this is the upper part of the mantle, and the characteristics of asthenosphere is that it is partly molten, and then it allows the movement of overriding plates at relatively slow rates. So the reason why plates are moving is because of the asthenosphere, knowing that it is partly molten, which is some sort of um, has these characteristics of liquid. No, all right. So now we are ready to talk about faults. But the first place, what is fault? So fault, these are the fractures along which block of rocks have moved and found at the boundaries of tectonic plates. So if you can see on the picture, this is an example of a fracture made no, or an impact of an earthquake. And the faults are classified by their movement. So these are tensional, compressional, and shear. Let's start with tensional stress. Okay, so as I said earlier, faults are classified into their movements. So in that case, let's talk about the first, which is tensional. So tensional tends to pull something apart. It happens in a divergent plate boundary. So if you can see here on the picture, the arrow represents the movements of plates. Okay, so they are moving apart, and this type of boundary is considered as divergent boundary, and what happens here is tensional stress. Okay, now the second one is compressional stress, or if you can see on the picture, they're moving toward each other, or it squeezes something, and it happens in convergent boundary. And the last type of fault, or the last type of movement, is what they called shear stress. If you can see clearly on the picture or the GIF, they move side to side, and it happens in transform plate boundary. Alright, so I believe that you are already good with the classification of faults based on their movements. So right now, let's talk about the parts of fault, because which is very important in knowing the types of fault. Let us know first what are the parts of the fault. So the first one is the fault line. So this is our fault line. If you can see clearly, the yellow line represents the fault line. Dip, the other part, which is dip, it is an angle that the fault cuts through the soil. So the cut that you can see clearly on the picture, it represents the dip of a fault. Then we have blocks. Now for blocks, we have two types of blocks, the footwall block and the hanging wall block. What are their differences? The differences is that the hanging wall is a portion above the fault, and the footwall block, it is a surface below the fault. So now we are ready to talk about the different types of fault. We have dip slip, strike slip, and oblique. Let's talk about first the dip slip. Dip slip refers to faults where movement of blocks is parallel to the dip of the fault surface. So as you can see on the picture, it clearly shows how dip slip or what type of dip slip type of faults forms or how do they move. So if you can see clearly, um, it has something to do with the movements of hanging wall and footwall as to their direction at the same time their the movement of hanging and footwall. So deep sleep has four or three types. So the first one is normal fault. A normal fault is formed by tensional stresses. I already mentioned earlier what is tensional, and this is a type of stress wherein they are pulling away from each other or they're separating from each other. So in that sense, this normal fault is caused by that, and which pulls rocks apart, hanging wall moves down, and then relative to the footwall associated with divergent plate boundary. So as I mentioned earlier, the divergent plate boundary has something to do with the tensional stresses, no? And in that case, in normal fault, this is caused by divergent plate boundary or tensional stress. Take note of that. Then another type of dip slip is the horsed and grabens. This is alternating a flipped and down dropped blocks. So if you can see on the picture, no, it shows how there is a flip and down dropped of blocks. So and we have horsed and grabens for that. Horse is the uplifted portion, and then the grabens are the down drop or the lowered portion. So that's it. Then another type of dip slip is a reverse fault. A reverse fault is formed by compressional forces that push the plates towards each other, and hanging wall moves upward relative to the footwall. So it is completely different, completely opposite to the normal fault. For normal fault, it is caused by tensional forces or tensional stress, wherein the fault or the different blocks will move away from each other, whereas reverse fault, um, it is formed by compressional forces and then it moves towards each other. Um, if you can see clearly on the arrow, it represents how reverse fault moves. And the last type of, actually this is actually a type of reverse fault, but to be specific, this is a type of reverse fault whose dip is less than 45 degrees, right? So now let's move on to the second type of fault, which is the strike slip fault. It is a result of sideway movement of blocks of rock, and blocks of rock move laterally. And the arrow represents how this type of fault move, and it's very self-explanatory. And the last type of fault is the oblique fault. It has both a dip slip and strike slip component formed by shear stress and tensional or compressional stress. And if you can see in the picture, we have reverse plus left lateral displacement, and the other one is normal plus right lateral displacement. Or it could be a mixture of different types of um, fault. Uh, it could be reverse and then right lateral, or it could be reverse and then left lateral. It could be of the two. Right. So these are the examples of um, fault movements observed in a large scale. So we have strike slip fault happen in San Andreas Fault, if you can see clearly, normal fault on coast of Somerset, England, and reverse fault on Grand Caucasus. I don't know how to pronounce that, but anyway, um, these are the examples of faults that are observed in a large scale. So now let's talk about the key points, important key points for us to ponder. First one is that faults are breaks in rocks where slippage has occurred. Second, faults is composed of fault line, dip, and blocks. And lastly, faults can be classified as dip slip fault, strike slip fault, and oblique fault. Right. So, um, to check your understanding, I want you to identify the specific type of fault in each illustration. You have this one, this, and then up to 5. Now, I want you to pause the video for a while and then answer it on a sheet of paper, and I will show you the result and we'll see if you really understood these types of fault. Alright, now you can pause the video for a while. Alright, so now I will show now the result or the correct answers in each item. Are you ready? Alright, let's see if you get it correctly. So these are the correct answer. For number 1, we have normal slip. Number 2, we have strike slip. 3, it's the same thing, it's still a strike slip. 4, it's an oblique. And then fifth one is a thrust fault. Or if your answer is reverse fault, then it's still correct because again, thrust fault is only a subcategory or subclassification of a reverse fault. Alright, so now I want you to ponder and think. How does a strict fault form? I want you to write that on your notebook, and then on our discussion, the further discussion on Zoom classes, I will ask you again this type of question and we'll see what did you get. Alright, do you have any questions? Kindly write down it on your notebook, and during our synchronous session, I will try to answer these questions. Alright, so if there's no question, you can, if you still wondering or if you still have questions in mind, you can actually watch this video again and take notes of the important details that are mentioned on this video. And then if you're still confused, no, do not be afraid to ask me one. All right, so goodbye and thank you.